After installing the SolveXL, open your Excel sheet. Open your Excel sheet and go to add-ins. Click on configurations. Before that, rename your sheets as problem and results. Results is optional, but you have to rename your sheet as problem, otherwise this will not work. So after opening the SolveXL from configurations, you see there these are all the parameters which is required for developing the evolutionary algorithm, which is GA here, genetic algorithm here. So you can do two types of problem. One is single objective, another is multiple objective. Clicking on next, this is the population of genes. That means at one iteration, how many number of solution the algorithm will generate. So lower will make the process faster, but it may or may not give you the optimal result. However, higher, that means 100, 200, 500 like this, this will make the solution or make the result optimal, but slow down the process. So it is always recommended that population size must not be more than 1000. Otherwise, it may happen that your computer will hang. Then it is better to use 50. I have found that with 50, optimal solution can be found, so it is no problem. Now here, this is the main algorithm. This is generational. There is three type of algorithm here. One is generational, one is generational elitist, another one is steady state. In case of genetic algorithm, what happens is at one iteration, different solutions are randomly generated, and among two solutions, crossovers are executed, and there, with the help of a fitness function, what they do is, in case of generational, always a better solution is produced. So, and the selection of better solution is based on the fitness function. So here, in case of generational, if you have generated 50 solutions, then 50 solutions or 50 new solutions are again generated, and again in the next iteration 50 more new solutions are generated. So the process is slow. But in case of generational elitist, the best two solutions are selected, and next iteration the process is forwarded with the help of these two optimal solutions only. So this generational elitist is more faster than generation. And in case of steady state, it is the most faster, but it is not optimal, or it does not yield optimal result like generational elitist and generational algorithm produced. So it is always recommended that generation elitist, the medium of the two, is suggested to be selected. And after then, these are crossover, single point, simple one point, or simple multi-point, or random, and crossover rate. This is 0.95, more the better, but don't make it 1, then the entire solution will be crossover. So it may happen some weird or infeasible solution is generated. So in case of simple 1 point, the chromosome is bred in 1 point only. So the genes are divided into same parts. In case of simple multiply point, chromosomes are broken in multiple parts through multiple points. So the divisions of genes are much more compared to simple 1 point. And as these crossovers are used to create new solutions, more the divisions, more new solution can be generated. And in case of uniform random, randomly these chromosomes are divided and crossover. So 0.95 crossover means among all the solution, 95% will be used for crossing over and 5% is kept as it is. So it is better like this value is optimal. And here rounded by rank tournament, how the best gene is selected, this you can select here. Tournament is the most optimal, followed by rounded by rank, and lastly rounded. So tournament is both faster and it results in optimal solutions. Rounded by rank is little bit slower and rounded is most. And next, this is gene, how much mutation you need. So keep it under 0.05. It is better in this way. And all this thing you remain like this, and you go to the main thing. This is the Excel link. So this gene type is nothing but the design variables, and this cell B2, B3, B4, B5, B6 are the design variables of the problem. Design variables means the value of which you want to know at the optimal scenario. So, and this is the lower bound and upper bound. Minimum how much value it can store and maximum how much it can handle. So to update the genes, in my case these yellow cells store the design variables. So I have used B2 to B6, B2 to B6. If in your case C2 to C6 stores the design variables, then you just select here C2 C6 and click on update. You see all this will change. Now this gene type integer bounded means the limits can have integer values, no fractions. But you can also use fractional values as the bounds, or gray integer bounded you can use, gray real bounded you can use. So gray is a special kind of variables where some are integers, some are real limits, but they are all advanced version of the genes. So for now it is better to know what is integer bounded and real bounded. Integer bounded means your design variables is constrained within lower bound and upper bound, which is a integer. That means for our case 0 to 1. And also this indicates that your solution can only be integer, not real number. These two are there, but best is select real bounded, because you need real number solution here. If you do not need, then you select the integer bounded. And here as it is, you are using 0, but use this 0.00, here 1.0, and so on, 0.00, 1. If you do not do this, then the software will automatically do it. Software will automatically do it, so 0 and 1 like this. Okay, then click on next. So where is your objective function? For my case it is D2, this one, sky yellow, lighter sky yellow. This holds the entire objective function. And then constants. So constant is that if any condition is not satisfied, you can penalize the solution. But for my case it is not required. So I will move into here. So this keep as it is. The special cases, and here you can mention how many number of runs you need, and for each run how many generation will be there, how many iterations will be there. So here I have used 1 run for 1000 iteration. You can use 2 runs, so 2000 iteration will be there. 5 runs, 5000 iteration will be there. And again you can change this in number of iteration also, or number of generations also. And random number generator means from which value the optimization will begin, because this is the basic difference between a heuristic optimization and linear optimization or non-linear optimization, where the beginning and finishing point is fixed. But in case of So what is happening? We have already selected the objective function cell. For our cases is D2. So I have right here D2 and I have ticked on update. Then go to constraints. So for now we do not need to use any constraint. Now then 17, keep it as it is. Now go to option. So one number of run, per number of run, 1000 iterations. If you use it 2, then 2000. 3000, or you can change the generation also. And as I have already explained, this random series, you can randomize the starting point, which is the specialized feature of multiplications. Okay, so keep it as it is. This is precision 3, code precision 3 means after point 3 digit will be shown, or if I do it as code precision 2, then after point 2 digits will be shown. And this chart update interval means 10 generations. That means the previous 10 iterations will be shown in the chart while you are doing the optimization. Click OK, your configuration value is ready. So this is your design value. This is your design variables. This is just a constant. This is the objective function. You see the function is written here. You will easily see that the functions are written here. And now you just click on run. Result sheet name results. This is already created here. If you have not created, software will automatically create it. And if this is your first run, then this will be tick off. If it is your second run, then you overwrite. Now click on OK. Now you are seeing the chart value, chart option. Only the last 10 values are shown here. We have selected after point 2 digits, so they are showing after point 2 digits. And as usual, this is the progress, this is the generation. I have said that there will be 1000 generation, so it will count up to 1000, then only it will stop. And this run is the counting the run number. One run, remember, one run is multiple iterations or multiple generation that you can change. Now it is going on creating. So this is a minimization problem. So 1 minus the function. So our goal is to minimize, and the minimum value is 0. So it is straight away it is making it 0. Now you see the results are shown here. These are the results, these are the design variables, these are the values, the base values will be automatically updated also. And also it can be seen here. The last part, this last row will hold the best value. Right? But still it is, in my opinion, don't depend upon the software. You will create your own checking method. So from that also you can select the best value. So this is the objective function. This is the penalty that we have not used. This is the fitness function utilized here. The values of the fitness function, and age means how many number of iterations or generations are done at which the best value was identified. Okay. So this is the thing. So here you are seeing randomize, I have said. So this is the random point and count how many randomizations done here. So ultimately you will get the best value from